This is the Chapter 8 Part 8 video. So in this video, we're going to talk about applications of substitution reactions. So far, we've just been looking at mechanisms. So let's see how one of these would actually work. So you can see, for example, here we have an alcohol. In this reaction, we're using a base, potassium hydroxide. Remember that the potassium is going to be a spectator ion, so we're just going to ignore it. And the hydroxide is going to be present in solution. It will deprotonate our alcohol and then do an SN2 reaction with our methyl iodide here. So let's look and see what this looks like. You can see here the mechanism of the reaction. Again, we're ignoring the K plus because that's just a spectator ion. Electrons are coming from the hydroxide to pull off that hydrogen. So this is a proton transfer reaction. And then the oxygen-hydrogen bond is breaking. The electrons are going to the oxygen. What we did there now is we created a better nucleophile. So an O- is going to be a better nucleophile than an alcohol. And this is a good nucleophile that can then do the SN2 reaction. So the electrons from the nucleophile, electron-rich, so this is our electron-rich going to our electron-poor electrophile. Remember, the carbon-iodine bond is polar, so we're going to have a big delta plus on that carbon. So our electron-rich goes to the electron-poor, and that's going to cause our carbon-iodine bond to break. Our leaving group is going to fall off as I-, and what we've done is we formed an ether. So this involved two steps. We did a proton transfer first, and then we did an SN2 reaction. So this is a multi-step mechanism that involves proton transfer. And we use this particular example occurred under basic conditions. So if you see these reagents, if you see a base present with an alcohol, recognize that what's happening is the base is deprotonating the alcohol, and then we're doing an SN2 reaction here with whatever our substrate is.